Okay, so to start with here, we have a big block of friend declarations. Again, a lot of this is commented out because we're choosing to basically use the member function version whenever we're able to do so, but we're still showing what it would look like if we were to do it as a friend function. And so we can start seeing that around here. So this is the plus equal operator. And And so we have the keyword friend here, like we saw back in chapter 9. The return type is coord ampersand, or meaning reference to a coordinate object. The name of the function is operator plus equal. So remember, the name of the function is always the full word operator and then the symbol for that operator. And then we have two parameters here that are both passed by reference. Remember, we said that one of the parameters must be an object or a reference to an object, and then the other could potentially be of a different type when you have multiple parameters. And so the idea here is they're both passed by reference. The second one, C, meaning the one that we're calling C2, is passed by constant reference because that one's not going to change, right? If we do a statement like C1 plus equals C2, the only one that's going to change is C1. So we pass that one by regular reference. And in general, you want to think about things like cascading member function calls, right? Which we talked about in chapter 9, how you can chain these operators together. Similar to what we did in chapter 9 with things like time, T1 dot set hour, dot set minute, dot set second, right? You're doing the same thing when you chain multiple operators on the same line, like C1 plus C2 plus C3 times C4 equals C5, or whatever. You're chaining all those function calls together. And in order to do that, you have to think about the return type. And so here we have a return type of the class type then, right? Because by having a return of a type of coord ampersand, now we're able to do things like, for example, chain the plus equal operator, right? Like C1 plus equals C2 plus equals C3, and so on and so forth. So you want to think about those issues as well when you're overloading operators, right? How are you going to support things like cascaded member function calls and chaining calls together? So this one would be a friend function for two coordinate objects, to add two coordinate objects together, but with plus equal. So this is going to actually change the left of the two objects. Likewise, we have this one down here. This is another plus equal, but this one has a coord object on the left and an integer on the right. So this one could be done with things like C1 plus equals 5, which would add 5 to both of C1's x and y coordinate values. And then we have some more here. These are all still friends. So we have things like the equality or inequality operators, right, for doing comparisons of equality. So in this case, equality would mean if the x's are equal to each other of the two coordinate objects and the y's are equal to each other, then we would consider them equal. Otherwise, we would consider them not equal. So here we still have friend, right? These are still friend functions. The return type for both of them is bool. And in this case, they're both taking in two coordinate objects. But this one is the equal operator, and then this is the not equal operator. And again, we're also using const whenever we can when dealing with a coordinate object. So since, these operators don't need to change anything since they're just equality, we made the parameters also const, right? So they're passed by constant reference. And then in the comments here, just kind of explaining different things that are going to be supported. Here we have operator minus as a friend function. Now, notice there's only one parameter here, and this is done as a friend function. So this is talking about negation, or what we call unary minus, right? If it were subtraction, there would have to be a total of 2 operands. So this just means that it's going to negate your object. So if C1, for example, has 3 for X and 5 for Y, then it's going to return a new object such that the new object would have -3 for X and -5 for Y. And notice the return type here, it is of the chord type, but it's return by value instead of return by reference. And we're going to see that come up with really all the common arithmetic operators, like plus and plus for addition, minus for subtraction, and so forth, and multiplication. And the idea is that when you think about a statement that would actually use this operator, and it would be a statement like this, for example, minus C1 semicolon, that does not change C1 itself. Or if you say C2, for example, equals minus C1, right? That does not change object C1. So what it's actually returning is a new copy object as opposed to the object itself, right? Because the object itself, again, is not going to be changed as a result of calling this negation operator. So when we do a statement like this, this is the function call to the negation operator where we pass in C1. That's going to create a whole new coordinate object where X and Y have been negated. And then if we combine that with an assignment operator, then that new copy object would be copied over to C2. So for that reason, right, we return by value instead of by reference, because we actually create a new local object within the function, which of course will be destroyed when the function ends, but then we return a copy of that with the return statement. So the arithmetic operators are going to be returned by value instead of by reference, right? So we have to make that distinction in terms of, you know, is the function, when you call it, is it actually changing one of the operands, or is it not changing any of them? And with things like the negation operator, the answer is it's not changing them, right? It's creating a whole new object, right? Whereas with things like plus equal, we are changing one of the operands, because C1 here, for example, or C here, we're going to have to actually change that, right? Because that's what plus equal means. It always changes the left operand, but things like negation don't. And that's also why, right, you know, if we're using these common arithmetic operators like addition or multiplication, if we want to actually store that somewhere, right, we have to also combine it with the assignment operator. Because of course, if we just say things like C1 plus C2 semicolon, well, that's going to call op plus, it's going to add them together, and it's going to return a new object. But then that's going to be the end of it, right? It's not going to change either C1 or C2. It's going to return a new copy object. But if you don't store that in one of your, the objects that you're actually working with, then you're in effect just going to lose that copy object and never be able to use it. So whenever we're using the arithmetic operators, we're usually going to be combining that also with the assignment operator in terms of actually using that result and storing it in another, in this case, coordinate object. So that's why we have some of these returning by value. We'll come back in a bit to things like operator plus plus and minus minus, because they're a little bit more involved. And then we'll come back and look at things like the input and the output operators. Now, down here, we do have some that are actually going to be active, the ones that aren't commented out here. And this goes back to some of the things that we hit on in the Word document, that there are some cases that have to be done as a friend function. In particular, when the left operand is not of the class type, we said that you definitely, in that case, have to do it as a friend function. And so there's going to be several that are active here as friends. And one is this version of op plus that does an integer first and a chord object second. That was one thing that we mentioned in the Word document. So that's going to add the integer and the coordinate object, where the integer is the first or the left parameter, and the chord object is the second or the right parameter. And then notice the return type here is chord by value. And it's very similar to what we said before with the negation operator, right? It's not going to change either of the operands that it works over, right? So when we call op plus in particular, right, it's not going to change that chord object C that we're passing in. It's going to create a whole new object. So it returns by value for that reason. And the same idea applies to the other arithmetic operators like multiplication and division and so forth. So we have a similar block here of those. Here we have, for example, this one here is the subtraction operator. So not negation, but subtraction. And we know which one it is by looking at the number of operands, right? Because this is a friend function, and the name of the function is operator minus. If we only had one operand, like we did up above here, if we only had one operand, then we would know that that would have to be negation. But since there's two, then we know that it's the subtraction operator. So again, some of the operators take on a different meaning based on the number of operands, right? The minus sign has a different meaning depending upon whether there's one or two operands. But here, since there's two, it means subtraction. And so here we have an integer first and a coordinate object second, right? Similar to this one up here for addition. And then we have some that are commented out because like, for example, this one here that's highlighted, this would be subtraction between two coordinate objects, which you could do that as a friend, but we're going to actually have this one active as a member function, which is why this one up here is commented out. But that's what it would look like if we were to do it as a friend, right? So friend, and again, chord object by value, name of the functions op minus, and then two coordinate objects that are both passed by constant reference. And then the rest of this is, again, kind of a very similar block here because these are all just arithmetic type operators. So the ones that are active are, again, the ones where the first parameter is not a coordinate object, because those are the cases where we have to do them as friends. The ones that are commented out are going to be actually implemented as member functions, which is why we showed it here, but we commented out the friend version. And another thing that we did here was, so we actually used this arrow operator, which normally does not mean exponentation, right, with primitive types, but we actually made it do exponentation. And so we'll see that come up here as well. And so we have all the common arithmetic operators like times, divide, modulus. And then again, these are all friends, right? And you'll also notice that this is all coming before we used any access specifier, because we know from chapter 9 that friend, right, does not correspond to either of public or private. Now we have private, and then these are our two member variables, just x and y for our two coordinates. And then under public is where we'll start to see the member function versions. And again, there's a lot of comments here just on things that are possible. So first one here is the assignment operator. Name of the function is op equal. Return type here, which we'll talk about this a little bit later, but it is a reference return type, and then also const, and then it takes in a coordinate object by reference. And then we have things like plus equal. And so here we have plus equal, two different versions. And now again, remember with the key thing to remember with the member function is there's always one parameter in addition to whatever you see in the parentheses, right? Because remember, there's also the hidden this pointer that's pointing at the current object. So we always have to take that into account here. So when we're looking at things like this operator equal, right, and we know it's a member function as opposed to a friend function, one of the parameters is the current object, right, the one this points at. The other would be this object C that we have in the parameter list, right? So we just want to keep in mind that this is actually two operands, right? Of course, for operator equal. And then likewise, two operands for operator plus equal. But as we saw before, if we did, for example, plus equal as a friend function, then we have to actually write out two separate parameters. With a member function version, we only have to write out the second parameter because the first one's being pointed out by the hidden this pointer. So it's more concise compared to the corresponding friend function, which is one reason why we're using the member versions when it's possible to do so. So those are two versions of plus equal. This one for adding two coordinate objects. This one for adding a coordinate object on the left and an integer on the right. And then we have things like the equality operators. And just like you would with any other function, you want to think about when you're dealing with member functions, you want to think about const and making the member function itself constant, which is something that you should do when the current object should not be changed, right? Meaning the one that this pointer is pointing at. So with things like the equality operators, we should definitely make those constant since it's not going to change there. Whereas with things like op equal or op plus equal, the current object is going to change, meaning the left operand. And then we have other things here like the less than operator. That's similar as well. That's another Bool return type. And then we have the prototypes for some of the operators that we saw before in terms of friend functions. And so when we're dealing with a unary operator, but as a member function, there's going to be nothing in the parentheses or the parameter list because the only parameter is the one that this pointer points at. So for example, here we're seeing on this line operator minus, meaning for negation, but as a member function. So the return type here, similar to the friend function version, is a coordinate object by value, because this is not gonna, right, it's not gonna change the current object, but rather it's gonna return a copy such that you're gonna negate X and Y. So return by value, and then the function itself is const. And then we'll come back later and look at things like plus plus and minus minus, since those are a little bit more detail involved there. And then we have a block with our arithmetic operators. And so remember, the way that we handled this was we had this block here of friend functions for all the arithmetic operators where you had an integer first and a coordinate object second, and those were all active. But for the other two cases where it's either two coordinate objects that you're working with or a coordinate object first and an integer second, with those cases, we chose to implement those as member functions. So that's why we see this big block down here. So these are the other versions. So basically for all these arithmetic operators, we have three different versions for either dealing with two coord objects, coord object first, integer second, or integer first and coord object second. So we're just handling all the combinations here. And so the prototypes of these are all very similar as we go through this. So this one here is operator plus for adding two coordinate objects as a member function. And so the parameter that we pass in is const, and the function itself is also const. since neither of the two coordinate objects are going to be changing. So we should, use const in both places, both for the parameter that we passed in, since it's passed in by reference, and then also for the function itself, so that way the current object also cannot change. Here on this line, we have operator plus with a coordinate object first and an integer second. So the integer is just passed by value, but the function is still const because we want to make sure the current object cannot change. And then all of these are returning a coordinate object by value, right? None of them, all of them are going to be creating a brand new object and not modifying either of the objects that are passed in, or the one object that's passed in, assuming it's a coordinate object and an integer that we're passing in. So all of these down here are const, and then whenever the other parameter is a coordinate object, then that also is made const as well. And then they all return by value for similar reasons. Okay, and then down here we have a constructor. This is actually a copy constructor because the parameter here in the constructor is a coordinate object by reference. And then we have a destructor and then another constructor with some default arguments here. And then that's the end of the H file. So that's the idea. And again, we'll come back and look at a few of these, like the input and things like input, output, and increment and decrement. But that's gives you an idea of the different things that we're going to be supporting here in this coordinate class. And so now we'll start looking at some of the implementation details. So first we have a destructor, and if we want, we can remove that, uncomment that, and that'll just show when the destructor is running if we want to see that when we run this. Here's the copy constructor, right, which we've talked about. Now we're actually seeing an example of what that looks like. And we know the copy constructor always takes in a parameter of the class type. And now it also has to be passed by reference because we saw that before when you pass in a class type, for example, to a constructor, when you pass it by value, right, it invokes the copy constructor. So of course that would mean if we were able to pass it by value, it would in effect be, infinite recursion. So, and beyond that, we said that in the general sense, you should be passing them by reference anyway. So that way you don't make a bunch of extra copy temporary objects. So we pass it by constant reference here, since it also, C does not need to change, right? Only the new object that we're initializing needs to change, but not the thing that we're passing in. And so our copy constructor here, though, is just taking for object C, where C, for example, would reference the other object from the application program. We're just taking that object's X value and putting that in the current object's X, and then that object's Y value and putting that in the current object's Y. So that's our copy constructor. And then this is the other constructor that can be used to pass in integers to initialize X and Y that way. And then here's our assignment operator, or op equal. And so, and again, the logic here is similar to the copy constructor, right? So there's sometimes there's that similarity between the copy constructor and the assignment operator, because they're both dealing with ultimately copying, right, the fields from one object to the other. But copy constructor happens when you create a new object. Assignment operator is something we can use with an object that already exists. So both of them are doing statements like this. But we also have the return statement here. And now the return value is a coordinate object by reference. And so we're doing return star this, which is actually what we saw come up when we looked at cascading member function calls back in chapter 9, right? Remember when we did those, the modified versions of things like set hour, set minute, and set second, where we wanted to be able to chain those calls together on the same line. We had time ampersand as the return type, and then we returned the current object itself, which is just, since this is storing the address of the current object, if we dereference it with star, then that's going to give us the actual object itself. So that's what we return back with operator equal, is just the object itself. So that matches up with what we've done here. Okay, and then here we have unary minus. And we mentioned before that this one is going to be creating a whole new object. And it will not modify the current object in any way. In fact, that's not even allowed since we said const here. And it returns by value. So the whole idea is what we really need to do here is we need to create a whole new coordinate object to where we've taken the current object's x value and we've negated it, and the current object's y value, we've negated it. Now, there's a couple of different ways that you could do that, which are mentioned here in some of the comments. So, for example, one thing you could do would be inside the body here, say something like chord C, negation of x, negation of y, and then return C. However, we can also just do what we did here and do this as a one-line implementation. And so what we're really doing is we're in effect creating an unnamed object, right? So we're just saying return chord and then negation of x, negation of y, right? And that's fine because, I mean, we're not going to be referring to C by name, of course, in the application program. Because anything that we create locally inside this function, right, would be destroyed when the function ends. But since we're returning by value here, the idea is we're going to return a copy of the object. So we're going to create a new object to where x and y have both individually been negated, and then we're going to return that back as a brand new coordinate object. And then we can use that in the application program. So we can really do that with just one line there, but this these two lines here showed an alternative way of doing it with two lines where you would create a named object C and then return C, but this accomplishes the same thing as well. So we don't necessarily have to give the local object a name here. We can just say return chord, negate X and negate Y. And so we're starting to see, really all this comes down to this whole idea of operator overloading. It's just the fact that we have to ultimately, of course, at some point, individually deal with all the member variables. It's just now, instead of having to do that in the application program, like we were before, now that's happening on the class side. So to actually negate a coordinate object, all it really means is to negate each of x and y and return that as a brand new coordinate object. And that's exactly what we're doing here. And it's going to be also very similar in terms of what we're going to do for the other arithmetic operators, like addition and multiplication, right? It's going to be very, very similar to the general idea of what we're doing here with this unary minus function or negation function. And now this is commented out because we already have, this is the active version of unary minus that works with only one operand. But here, this is what it would look like if we were to do it as a friend function. And it's very similar, except the difference is, whereas here we're working off of the current object, so we can say things like negation of x, meaning negation of this arrow x really, and negation of y, or negation of this arrow y. Of course, with the friend function, there is no current object, so we have to pass in the parameter. But the only difference here is now we're going to say return chord and negation of c, meaning c up here, negation of c dot x, and then negation of c dot y. But other than that, it's the same general idea as the member function version. So they're all similar to each other. And then here we have operator equal equal, or our equality operator. This time we just return a Boolean result, right? Meaning we return true or false. And then there's a couple different ways you could do this. You could do this, in terms of things like if statements. But in the end, right, we just need to return either true or false correctly. So we can also do this really with one line here. So evaluate this expression, meaning compare the x value of the current object and object C, return true if they're the same or false otherwise, and then compare y for the current object and object C. And then the only way that you return true as the final value is if both of the comparisons individually both return true, meaning we only return true if x for both objects are equal to each other and y for both objects are equal to each other. And then this is what the friend function would look like, very similar, except now we have to pass in both objects, and then it's going to look like this, right? So again, we're seeing why the member function version is a little bit more concise, right, compared to the corresponding friend function. So here we have to say things like c1.x equals c2.x, and then same thing for y. Now, not equal is a little bit interesting here in terms of things that we can do. So we showed a couple of different things that are possible here. One way is you could just directly evaluate it in terms of a logic expression, like what we did up here in the commented out portion. Or it turns out you can implement it in terms of operator equal equal. So it is possible when you have, because these are just functions, right? All these are just functions when we think about these operators. And so in that sense, it's possible to have one overloaded operator function call another, right? We can implement one in terms of another. And so what's happening here is we're actually implementing not equal by having it call op equal. And so the idea is that this is operator not equal as a member function, which is working with two different coordinate objects, one of which is the one that this pointer points at. The other is the one that C is referring to. And this statement here, as long as we have a coordinate object on both sides of the equal equal, then that's going to trigger a call to op equal equal, meaning the op equal that we have active here. Because star this, right, that's going to dereference the this pointer and return the current object. And then C is also a reference to a coordinate object. So we end up with an expression here where we have a coordinate object on both sides. And that's going to lead to us calling this operator equal function up here. And then from there, it's going to return true or false. And then we just negate that to return the final value, right? Because if equal equal returns true, then not equal, right, should return false. Or if equal equal returns false, then not equal should return true. So we can do things like that, right? So sometimes these kind of things will come up where we have one overloaded operator function call another. And then this is the commented out, right? Commented out version of not equal. This is the friend function. Very similar to what we had above, but just like the other cases, we have to pass in both objects separately. And then we could do the call like this, right? Return C1 equals C2, and then negate that result. And now we'll look at some of the others here. So here we have the operator plus for addition. This one here is a friend function, so we have it commented out because the member version's the active one. But similar to what we saw with the unary minus, remember the return type for these arithmetic ones is return by value. And then the body is really just can be done in one line because all we have to do is create a new coordinate object. And so you'll notice here, what we're doing is we're taking the x values of both objects, we're adding them together, and then we're adding the y values of both objects. So this is going to create a new coordinate object where the x value is going to be the sum of C1 and C2, and the y value is going to be the sum of C1 and C2. So very similar idea compared to what we did with things like unary minus. And it's really going to be the same general idea for all of these various arithmetic operators. And then here we have the addition operator where the integer comes first and the coord object comes second. So that one has to be done definitely as a friend function. And so what we do here is we take that value, that integer value, and we add it to both x and y. So the same integer is added to both x and y for object C, and then we just return that as a brand new coordinate object. And then likewise, here we have another version. This is the, this one's the active one for two coordinate objects. So we did that as a member function. And so here, just take the current object's x value, add it to C's x value, and then the current object's y value, add that to C's y value, and then return that as a brand new coordinate object. And then again, the rest here are going to be very similar for the different combinations. So this one is a member function where the coordinate object is the first parameter and the integer is second. So we just add that integer to both x and y and then return that as a new object. And so on and so forth for the rest, right? So it's going to be the same general idea for the other things like subtraction operator, multiplication, division, and so forth. Division, we did a little bit more here because of things like dividing by 0. So we just had a little bit of exception handling here. If we detected, so when you're doing things like dividing, for example, two coordinate objects, if the second one, which is the one that would be considered the denominator, if either of its x or y is equal to 0, then we throw an invalid argument exception. Otherwise, we just create the new object as we normally would. So you're going to see that come up with things like the division and the modulus operator. Is if the second parameter of the two, if anything is 0 related to that, throw an exception. Otherwise, create the new object, and so forth here. And now one thing we did here a little different was we actually made this, this operator do exponentation, and it normally does not do that. And so what we did to do that is we just used the help of the POW function. So this would be that, that caret or up arrow operator as a friend function with two coordinate objects. And so you'll notice here, very similar to the others, we have one line of code for the implementation, right? Return a new coordinate object. But as far as actually doing the exponentation, we just use the POW function. So what it's doing really is it's taking the first object's x to the power of the second object's x, and then likewise the first object's y to the power of the second object's y, and then returning that as a new coordinate object and returning it by value. And then like the others, we did the different combinations here of two coordinate objects or a coord object and an integer in both of the orders. So we're going to have three different versions of that. And then we have things like the modulus operator here as well. So similar to division, but for getting the remainder instead of the quotient part of integer division. And then we have multiplication. But again, the arithmetic operators are all basically the same. So it's just kind of the same thing, but for each different operator. And then we have plus equal. This is somewhat similar to the assignment operator, except it's plus equal. So just take the second object, right, and then do a plus equal with both x and y, and then return the current object with star this. So we're seeing that, again, some of them are different from the others. The ones that were returning a reference, we've been doing return star this. The ones that have been returning a coordinate object by value, instead of saying return star this, we've been creating a brand new object and returning that. And then plus equal with the integer here. And then we have some of the last ones down here. And so we just took, again, we took a lot of the common operators and overloaded them here in this chord class. And we've seen the idea now with a lot of them. And then in the application program, this is definitely a good thing to kind of, test, change things, play around with. But it's really just testing out a lot of these different operators here. And because of the way that we've implemented these, we can also do a lot of the chaining and the cascading. So that's why it was so important that a lot of these functions had a return type that was either, for example, chord or chord ampersand, right? Because that also is what's making the chaining that we commonly want to do, what's ultimately making that possible. So definitely, there's some good tests here. And again, it's good to kind of play around with this too. So after we put this up on Canvas, and there's some things that will, as we continue this discussion next week, we'll get into some of the more details here. We've hit on kind of a lot of the basics, but we'll talk about things like, for example, why the assignment operator oftentimes will have const chord ampersand as the return type instead of chord ampersand. We'll look more at things like the increment and the decrement operators and how they work, because you have to think about both prefix and postfix, right? And there's a specific way that we can distinguish the two from each other. And we'll also look at things like the input and the output. So that one's a little bit, the input and output are a little bit different, as you kind of briefly see here. One way that this is similar to something that we've already encountered is the input and output operators are another case where the left operand is not a class object. So you can imagine things like, for example, in the application program here, we want to be able to do statements like this or statements like this, where the function call would be a cin, for example, on the left, or maybe a cout on the left. So it's that same issue ran into again, where the left operand is not of the class type. So we'll see that things like the input and the output operators, right, those have to be done as friend functions, similar to the case where when we were adding, for example, integer first and a coordinate object second, we said that had to be a friend function. So the input and the output operators, those are always going to be done as friend functions. And similar to just like any other operator overloaded function, you have to think about inside the function itself, how you're going to individually deal with each of the number of variables, right? And so here, for example, with the output operator, we can see that we're individually referring to both x and y, and we're really building a stream here, which we're going to return. So we'll look more at, you know, the different types here as far as the O stream and how this is all coming together. Um, but we're just kind of seeing that briefly here as we wrap up. So we'll look at things like the input operator, and again, cascading comes up here too, because we want to be able to, for example, see out several chord objects back to back on the same line, or maybe see in on the same line. So those kind of things are going to be possible. And then we'll look at the increment and decrement operators. So that's actually really interesting compared to some of these others, because there's certain things that are going to happen to make it work, right? So we're going to be able to do things like both prefix, for example, like if C1's a chord object, right, plus plus C1 or C1 plus plus, right? We'll talk about the way that's going to work in terms of how you're going to use, because the name would still be the same, right? Is the idea, right? So regardless of whether you're doing prefix or postfix, the name of the increment operator is always operator plus plus. And so one thing that comes up is we have to think about, you know, how we're going to distinguish prefix from postfix. So we'll talk about the way that we do that. So they're a little bit more involved with your things like your increment and decrement operators, but we'll look at those some more, and then we'll look some more at the input and the output operators, and how those are working to support things like the cascading and so forth.